My name is Abby,
And my name is Jasper.
and we are presenting our comp sci project titled Does the Education Level of Parents Affect High School Seniors' Success in School?
So to give a brief overview of our project and what problem we're trying to solve, our project examines the relationship between parents' achieved education levels, such as high school diploma or post-secondary, and the amount of failures of their student children of age 18 in their final year of high school. The information is from the student alcohol consumption data set, which is a host of super intriguing data columns regarding student lifestyle. This particular relationship was chosen from amongst the dozens of data categories because it asked the question, are students more likely to succeed in school if their parents have high levels of prior education? And is there an influencing factor on the academic trajectory of their children?
To explain a little bit about how we use systematic program design to solve the problem and some specific design choices that we chose, we incorporated nearly every facet of systematic program design that we've learned in this class so far, from defining enumerations and compounds for chosen parts of the data, to running for loops and lists as filters for the data, to using composition to string together helper functions for thorough filtering, and plotting functions for visualizing our investigation. And we had to decide what types of data we wanted to work with, such as strings or numerical data like ints and floats, and if we wanted to parse specific types into others, such as transforming our failures enumeration into basic integers. We also had to decide how to design helper functions that would allow us to match up an average number of failures based on the independent variable, which we achieved through the specific helper function called calculate failures per ed level. And this pulled on multiple other helpers, such as those that filtered for age 18 and average combined education levels of parents.
So to demonstrate how we solved the specific problem, first we performed a read function that allowed us to tinker with the data file. As we have shown, we defined failures from 0 to 4 plus as an enumeration for easy future use, and the base columns of investigation, failures and parents' education levels, as compound to specify we only wanted to pull from these columns. Then we created a primary filter help function that only pulls the data of students who are of age 18. Then we created some clever helper functions that combined and averaged the education levels of the parents, as well as functions that created lists of the numbers of failures parsed as ints and lists of the average parents' education scores. So these helpers culminated in a solution where we could compose a function that strung them together using composition and calculated the average failures per education level, plotted as a line graph. As can be seen, our line graph of our investigation looks very similar to the proposed graph on the left. This is a drawing that we made during the milestone systematic program design process. And the interesting difference is the unexpected jump of failures around the 3 on the parents' average education levels. This deviates from the otherwise negative relationship displayed.
Next, regarding the parts of the project that were most difficult for us, we ran into a lot of roadblocks regarding how exactly to plot the number of failure of students against the average parent's education level. And the primary issue was figuring out if we would need a bar graph or a line graph, considering the x-axis value of education levels was not necessarily continuous. And after making a host of helper functions to get average education levels and attempting to plot them against failures, we realized that we had not ran helper functions to plot the average failures per education level, so one value per each education levels. And we were getting tons of interconnected values on each education level due to all the individual students. And to overcome this, we tinkered around with line graphs that featured only the average failures per education level on the x-axis, as well as bar graphs dealing with the frequency of failures per education level. And we realized that the former worked really well for our data, and this was nearly exactly how we'd predicted it in our milestone planning.
So regarding the specific ways in which our systematic programming design skills could help us solve future problems in our topic, we could use these established programming design skills to investigate other relationships within the data of student lifestyle, such as the columns of happiness or amount of time spent with friends against the amount of weekend alcohol consumption. These are potential ways to tackle the negative aspects of high school student life. By plotting relationships in the data, such as we did with the parents' education levels and number of class failures, and all the other possible avenues that we could explore within that data set, programmers like us could help visualize and shed light on potential ways to positively impact student life. Thanks for listening.
Thank you.